Hi, this is Richard Collins, and I wanted to go over quickly something I started. This is the next thing. Let me move that out of the way in a moment. I'm going to be looking at the school enrollment in California in 2018 in a minute. So maybe just that's where this came from, so you can see the URL up there. Let me put that out of the way. Okay, the last video, I was just trying out some ideas to look at the space of possibilities if people were allowed, or as they begin to work globally, regardless of their country, and looking at groups of various sizes. If it's just pairwise, there's a factor of 13 increase in the size of possible combinations if you break down the barriers between countries. So there are 13 times more possible pairs when you can draw from the whole world than if you only take them within each country. So this pairs count here, this is n times n minus 1 over 2, which is the number of pairs of all the people in China in 2000 with this number in 2019. And then the number of pairs in India and so forth. I added all those up, which is this lower number, the 2.23 times 10 to the 18th pairs, unique pairs, and then the number of pairs if you look at the whole population of the world and draw from there. So that's a significant, tenfold. That would be 1,000%, actually 13,000%. Sorry, I'm tired. Okay, so if you go to triples, like forming larger groups, the number of possibilities goes up very, very rapidly. Just a quick note. I got stumped in here because I was using a very simple, hand building each of these formulas. And then I realized that it's recursive, that this here is just the previous number times the population minus the previous number here times this number. Okay, so I did that because I got out here and it was just the method was burdensome, and I only could get out to like the tens, combinations of tens. So I took a few minutes and rearranged the formulas, and now these are all, you'll see that all the formulas are identical, and what they're doing is referring to, and this one is referring to J7, that's this row. So it's dividing by this number and multiplying by the previous number, and then the population minus that. You can look at it. I'll see if I can get this posted somewhere where you can take a look. But it allowed me to answer a question I had, which is I didn't know. I thought it was about 10 to the 300th. And so I went out here. This actually starts failing. I can't do the calculation of the ratio because the total the total number of combinations in the whole world is going over 10 to the 300. I think it's about 10 to the 308th. 308 decimal points in there. Pretty large number. I'm trying to get comfortable doing these kinds of calculations. The space of possibilities when you go DNA. I think there are 16 characters in the DNA sequences, you know, and then there are 2 billion possible, 2 billion elements in the sequence. And so that's basically 16 raised to the 2 billionth possible combinations. It's probably restricted less than that because only certain ones are more likely, but that's roughly the kind of calculation that you do. So anyway, so I can at least go out and look at the actual, values in here. And, I mean, we're getting, basically we're getting, if you allow the whole world to talk to itself, everyone in the world talk to each other to form groups of, 35. Well, not everybody's going to be in groups of 35. And once you choose certain groups, that kind of limits. People aren't going to jump around randomly, moment by moment. Now, robots could. Okay, the computers could possibly do this. I was going to say that, or I was thinking about it yesterday. Okay, here, everybody is, onesies. So there are roughly, I think that's a little high, but it's 7.7 billion people in the world in July 2019. I think that's a little more than it. Anyway, but one by one, if you take them singly, then the number in the world is the number in the countries, and you don't gain any benefit. But if you go to pairs, you get this factor of 13 increase in the size of the space of possibilities. And if you go to triples and so forth. Now, okay, 2 times 10 to the 9, or 3 times, that's roughly 3 times 10 to the 19th is like, 10 billion times a billion. Well, that is, that's larger than, we can cover. Now, if you get a computer running, 24 hours a day, 7 days a week, 365 or 366 days a year, then it can crank out numbers of that scale. Okay, and that is where the new space of possibilities is occurring. Now, people, I'm one of them. I'm gonna die sometime, and I'll lose 50, 60 years of hard work. It'll just disappear in a moment. Bang, gone. I can't write fast enough to write down all the experiences and things I've done. I mean, I've tried. I could write a paper a day and still not cover everything. But the things that, what we can do is get people involved in guiding computers to gather the information that's most relevant and useful for human survival. And ultimately, we're going to have to worry about computer survival as well. I think they're just going to go off and do their own thing at some point. Hopefully, they'll be grateful. All right, let me move on here. So, what did I learn here? You can, with a fairly simple algorithm, you can cram into Excel and get out and at least see the numbers and think about the concepts involved in, people forming groups of various sizes. I'll find a better way. I want to get some real examples. In fact, let me move this one out of the way. And here, what I did was I went, let me get that page back here. This one. Okay. I actually have done this in more detail already before, so I just was kind of revisiting. I just, California data or something like that, I searched. Well, here's enrollment by school, so I just grabbed, I don't want the file structure, I want the data. So I downloaded the data and loaded it into Excel. So that's where this stuff is coming from. And if I look at this, the raw data comes in like this. It's not, I would prefer a different way, but this will work. And I said, let me narrow down here. I sorted it immediately by school, and then by gender, and then by ethnicity, just to get it easier. They didn't sort it so very well. Now, then I said, well, let me just look at the total in the first grade. I want to keep this real simple example. Okay, so here's California first graders. I don't know if you use pivot tables. What I did was I just got in here. I'm in a table, and I did this. I said, let's see, that's my thing for generating a pivot table pivot chart. So I click that, and I just take the defaults. Next, there's a green border around here. It's highlighting this entire table. I just say next. Because I've already used the table once, it's asking me, do I want to be efficient? And I'll say yes, just use that one, say next. Okay, and I'm going to put this in a new worksheet. I'll just repeat what I did before. So I'll finish that. So it comes up here in an empty space. This is where the pivot table is going to go. And you're looking at this. And the thing I'm going to put here is by school. So I like names of schools. And then I'm just going to take the first graders and put them here. And it's adding across the ethnicities and genders to get these totals. And I'm going to go in here. I'm going to sort descending. That's I put my most commonly used things here. There's other ways to get it, but so anyway, in there. So there's this one school. They've got 2,400 kids in the first grade. I'm not sure that's reasonable. Maybe I got something wrong. This is a demonstration of breaking things up, not so much exact. I can go back. Well, the framework of this thing is done. I mean, I've got all the numbers in here. If I have to change the interpretation, then I'll do that. But let me just demonstrate. So that's how I got to this one. And I'm assuming, this is good. It doesn't matter whether this is, maybe that's a district or something. I don't care. So here's a case where some breakdown, there's 2,400 people who could work together. In this case, I'm talking about first graders working together. So this is the number, and this is the number of possible pairs, n times n minus 1 over 2. So those are the pairs that this many people could form. Okay. Now, exact same thing that I did before with countries. I said, supposing we had this breakdown of groups, so that there's a group of size 2406, a group of size 2104, a group of 897, a group of 671. So I get all these different sizes. And actually, if you scroll down here, let me get this. Okay. You see they get smaller and smaller, blah, blah, blah. And then there's a bunch that are 0 because they have no first graders. Whatever. I don't just think, I don't quibble about that stuff. There's lots of memory. Just use it. And then, and you'll see there are 448,020, I can't read, 28 people. And I brought that up here. I calculated its combination. So this here is that times that minus 1 over 2, n times n minus 1 over 2, for n equals 448,028. That's 100 billion combinations there. That's when you treat all the kids. I hope this is correct. I'm just, it's a demonstration here. I'm not, if somebody wants to go double check me, they can find exactly how many first graders are there in California. I want to do all first graders in the world. I would like everyone who's going through that age, which can be, you could have somebody doing first grade type work and they're 3 years old. You could have somebody who's doing first grade work and they're 25. Okay? I don't care what their particular situation is. I don't distinguish by ethnicity or sex or background or country or anything else. if they're capable of doing that work, if that's their moment in life, then they could be working together, right? Okay, that's all. Now here, okay, so what is the multiplier here? So here, if you limit these kids to only their own school, now that's actually a big jump. I'm going to talk about grade, being limited to a grade and limited to a school or limited to a state. Here, if all the kids in the state work together regardless of where they are, they're working through the internet, they can work in any combinations, they can work all of them together as a group, all of those things are possible. Then here, in a simple way, you get a multiplier of about a little over 2,000. It's 2,224.6 because I did a ratio. So that means, just in terms of the pair combinations that are possible, it's 2,000, more than 2,000 times better in some sense in terms of like having more possible combinations to draw from to allow kids to work within the state, not just within their school. Now let me go one step further. Here, I stuck in class of size 30. It goes, if I can find the distribution of first graders by class size, I would use that for an example. If that's a easy thing to do if I take a few minutes and find the data. Here, there are 435 pairs within a class that has 30 kids, 30 first graders in this case. And let's see if I can explain this. Okay. So, if you limit the kids to only their class, they're stuck at 435 pairs. They can only interact with the people in their class. But if you allow them to work within their school, right, then you have 6,000 or 7,000 times more combinations, okay, depending on the size of the school and so on. Now, okay, so I hope you're getting what I'm doing. So I'm basically saying, okay, right now in our world, the world we have today, for the most part, first graders only talk to the kids in their own class. Yes, they're out there playing games. Yes, they're out there probably starting to email and talk to kids outside their class, but their space of possibilities is fairly limited. Now, I know there are 50,000 issues you can bring up here, but and maybe I should have chosen, entrepreneurs, a company with 2,000 employees or, a company with 10 employees, but anyway, but these numbers generally work that way. And I'm just looking at pairs, okay? All I'm trying to do is demonstrate that the potential comes from interactions. And if you have more interactions, you have more potential. Okay. How am I doing on time? I don't want to make these too much longer than this. Let me see if there's anything else. Let me pause for a moment. Okay, I'm going to pause. Okay, I was going to shift to a different thing, but I decided to try. I just wanted to show you how. Let's just do. I think I can do 12th grade here. Okay, and so this is that sheet that I was demonstrating. So I did the crosstab here. These were grade 1. Now what I want to do is shift this to grade 12, okay, and let's take off, let's see, grade 1. Did I? Yes, I pulled it off. Okay, all right, so this is their let's do the same thing. Let's sort it that way, and we'll just run through the same thing. So this one, I'm going to do equals. You have to use the numbers here. So this is cell B11, B11 times B11 minus 1 over 2. So that's the number of combinations I'm going to. There, you can run this at slow on. You can run it at quarter speed on YouTube. So if you want to try that, so let's go to the bottom here, and I'll put an X here. Go to the top, Control C, down arrow, end. I do the Shift, end, down arrow, Enter. That gives me the thing. So these are pairs, and I'll center it. And what I'm going to do is take the sum of that, click on that. I got the Shift key down, end, down arrow, Enter. Okay, so that gives me the sum of that. Let's bring this number. I'm doing a plus sign. I'm going to scroll to the bottom. Oops, missed. I missed. There. Okay, there. And I'm pointing to that total. Okay, so I have it in there. And then this is my n times. That's the sum. Let me take one of these, which has the correct formula. Control C, put it in here. Control V. Okay, and then divide. So this is this. All kids, all 12th graders, 490,650 of them in pairs, that number divided by the number of pairs if they only interact within their school. Okay, and that's a multiple of 963. That's interesting. There were more possibilities for elementary school thing, and I'm just coloring it and putting a border around it. Okay, so that's the multiplier there. So there's about 1,000 times more possibilities if kids work within the state than within their own school. Okay, so that's just showing you the steps how I built that thing. It's pretty simple. I have the advantage of doing this for the last 30 years every day, but it's not hard. I wish I could extend Excel to add a lot of new features, but the programming within Visual Basic is just crude beyond belief. So anyway, so all right, that I just wanted to show you where those Excel steps I had to go through to do that. It's not hard. It's just tedious. Okay, all right. So anyway, but that's I think this is a good conceptual approach for at least kind of getting some of the ideas in mind. What are the advantages of working? Have for California, for instance. Okay, let's have all of the kids be able to talk to each other. Okay, now if you allow every kid, regardless of grade, to work with every other kid, you're kind of golden. I mean, that's 120 billion roughly combinations that occur. Essentially the space of connections is infinite for young kids there. Now, if they're within the whole world, it gets much larger. But I'm going to say it again. I think everyone who's learning, introductory. Let's see, when did I learn? I tried to teach myself Chinese. I was in the third grade, maybe fourth grade, somewhere in there. Third grade. Anyway. I didn't have anybody to talk to. I really wanted to be able to correspond with people worldwide and say, look, I'll sit in on the class and do it, or share what I've learned, because I just sit down and do it, and then, if people would use some of the things I've learned, they would save a lot of time. So anyway, whatever. All right, let me stop here.